This is a video introduction of TDP data systems to the Defense Advanced Research Projects Agency, or DARPA. Based in Palo Alto and operating globally, TDP Data Systems divines the future and pulls it into the present. TDP does this through a stepwise, methodical process that collapses the process for solution exploration and generation. TDP transforms napkin sketches into reality with a path forward in real time. TDP's approach was developed to address accelerating advances across STEM and innovation, which is causing faster technological obsolescence and greater potential for leapfrogging incumbents in industry and geopolitics through disruptive innovation. TDP divines the future by turning disparate data from 50 million databases, sets, and tables into actionable information in real time. This includes assessing 4 million startups, 40 million patents, and 200 million research papers and abstracts. This allows TDP to have its finger on the pulse of global innovation and can illuminate the art of the possible both in theory and in practice. TDP is agnostic to scientific area, research topic, technology, industry, pain point, use case, mission, and geography. At the bottom of the slide is a link to a video scrolling through TDP data sources. Using machine learning, TDP restructures the data across these various data sources based on keywords to form a customized data set for the area of interest. TDP also uses machine learning to exponentially expand the number of keywords it is working with for the area of interest. This increases the potential solution space and provides greater optionality. TDP converts the data into actionable information by combining advanced computing intelligence with human intelligence. Combining both types of intelligence offset the respective biases of both. Advanced computing can assess vast amounts of data and do so objectively, which humans cannot do. Humans can assess new and novel situations which computers cannot do, now or for the foreseeable future. GSA asked TDP to participate and present this approach during its 2024 procurement hackathon. At the bottom of the slide is a link to TDP's video for GSA. TDP uses advanced computing to algorithmically assess, score, benchmark, and rank every type of resource contained in the databases it is accessing. Resources include research, patents, IP, innovation, models, processes, supply chains, infrastructure, startups, organizations from startups to Fortune 500s, and talent. TDP's algorithmic assessment populate objective scorecards that humans can further act on. This process helps direct humans on where to focus across vast amounts of data and improves the allocation of that limited and expensive resource made up of human analysts and decision makers. TDP demonstrated its solution to NIWC Atlantic and won its 2022 challenge to improve its rapid staffing process. Again, TDP uses its process to score, rank, and recombine any resource from people to IP to organizations. At the frontier of science, emerging technologies, and startups, there tends to only be partial solutions. As such, TDP combines these pieces to form a holistic solution to address specific mission needs or pain points. These holistic solutions make up a whole that is greater than the sum of the parts. Pieces of a solution are drawn from the various resources TDP algorithmically assesses, scores, benchmarks, and ranks, such that they can then form new combinations for holistic solutions in real time. DOE asked TDP to present its approach at Berkeley Labs' NextGen AI workshop in 2024. TDP's approach not only provides for solution generation, but matches that with predictive analytics to enable getting left of boom in real time. US SOCOM and SoftWorks asked TDP to present its technology and process in 2024, and at the bottom of the slide is a link to TDP's video for US SOCOM and SoftWorks. TDP presented how it could provide solutions in real time to address contested logistics in the Arctic and Indo-PACOM. TDP's first step was to expand the clusters of keywords that included energy storage, drones, metamaterials, and 3D printing. TDP's second step is to restructure and combine the various databases based on the clusters of expanded keywords. Databases that were restructured included those for research, patents, and startups, and they were then joined. TDP's third step is to select from its library of over 200 proprietary algorithms and models to be applied to the restructured dataset. Examples of TDP algorithms include build versus buy, the ability of a startup to execute its claim, and how novel is a research paper. The algorithms then populate scorecards with objective scores that humans can then further evaluate with their subjective lens. TDP's fourth step is to cross various types of technologies to find the proverbial needle in a haystack that can then serve as a component included in the holistic solution. On the left is a cross of over 6,000 startups focused on 3D printing and close to 6,000 startups for drones, and the overlapping 63 startups doing both. On the right is the cross of 3D printing startups with over 31,000 startups focused on metals and the close to 500 doing both. TDP's fifth step is to group, analyze, and combine the various components and their cohorts to form a holistic solution, which TDP refers to as an ecosystem map. TDP's sixth and final step is to generate a graphical representation of the holistic solution, or TDP ecosystem map. This TDP ecosystem map is to support US SOCOM for contested logistics by providing for real-time modular rapid manufacturing of customizable attritable drones for the Arctic. This graphic describes a small-scale manufacturing pod that can be airdropped or towed into forward operating positions. Inside the pod will be multiple 3D printers for different materials, such as plastics and metals, for rapidly manufacturing customized mission-based attritable drones. To power the system, solar panels on the roof will collect solar energy with the ability to pull out additional panels, and alternative energies like thermoelectricity from sand, aka sand batteries, and snow-based triboelectric nanogenerators, depending on the environment deployed. Onboard batteries will then be used to store excess energy to power systems during low solar capture times. Metamaterials will be used to cloak the system to radar and heat signatures. TDP generates these ecosystem maps in an hour or less. The next step would be to conduct a proof of feasibility and then proof of concept. TDP provides its solution through its advisory services on top of its platform as a service. TDP has been in market with the Fortune 500 and Global 2000 C-level around the world since 2016, academia since 2018, starting with Stanford, and the federal government since 2021, including supporting NSF and deep tech. At the bottom of this slide is a link to TDP's 2018 presentation for Stanford and a link for TDP's 2024 video for deep tech, NSF, and the Angel Capital Association. Here is the URL for TDP's website and a point of contact for TDP. Thank you for watching this video.